So my name is Joanne Harbinson, and I work for Saugeen Valley Conservation Authority, and together with Hannah McCann from the Lake Huron Centre for Coastal Conservation, we pulled this together over the last month and a bit. So just for logistics, if you haven't noticed, the washrooms are out to the side there, and we'll kind of get started here. So yeah, today we're going to hear about lots of good things from Robin Davidson-Arnott as well as Pete Zuzak. So I'm not going to dwell too much longer on some of that. I want to thank our funders from Environment and Climate Change Canada, as well as the Ministry of Environment and Conservation and Parks for the funding for tonight and to help us to provide this live streaming aspect of it as well for those who are out there. Today is February 25th, 2020, so that in the future you'll see this on the sheets as well. And when you're looking at it later on, you'll know. So conservation authorities, we're across the province, 36. Saugeen Valley Conservation covers this area as well. We look after the local watershed management as an agency delivering services and programs that protect and manage water and other natural resources in partnership with governments, landowners, the municipalities, and other organizations. The key focus for conservation authorities is implementation at the local level. Conservation authorities widely partner with all levels of government, landowners, the private sectors, other stakeholders, and generally our funding for conservation authorities, municipalities provide upwards of 31%, probably 40 to 45. The province, get that updated, maybe it's 3.5, maybe it's 2%. Very little from the federal government, only on project basis, and then lots of self-generated revenues as well. There's an overview of all the programs that we offer in our watershed, and our planning and regulations staff are here to give a presentation after our break, and they'll talk about all the things that you need to know about along the shoreline. The flood warning is very important to the watershed, so people understand what's going on. We understand what happens in the fall, and then we can predict the flows and whatnot in the spring and identify where the low-lying areas that might receive flooding. The municipalities are notified, and so on. Our forestry department, you'll see some banners around here should you need their services. So today we are here to talk about Lake Huron shoreline. You're going to hear lots of good information from our speakers. But living by the lake, why do we come here? The reasons we come here is because it's beautiful. It's natural, gives us tranquility, and of course the beach. So many attributes as to why we come here. However, there's many trade-offs as well. By living at the lake and the nearshore areas, we have neighbors, of course. You can have neighbors close by. We have erosion, so the water-borne and lake-borne erosion, the changing in the water levels, we're going to hear about that. And then access to the beach. I mean, it's very important not only as landowners and property owners, but as municipal owners and as the public wanting to get to the beach for recreation purposes. So right now, according to the U.S. Army Corps of Engineers, I believe the level is 177.24 meters today. And our speakers will speak about this in respect to our high-level water. But just to say, you're going to hear lots of good information. This picture was from 1985, and that was taken along the shore road between Port Elgin and Southampton, if some of you are from that area. So that's kind of it for my introduction, to welcome you here from across the watershed, the shoreline, to those who are online listening, and to those who will in the future hear this. We hope we can provide you with some valued information that you can use as reference information. I'd like to introduce now Robin Davidson-Arnott, and Robin, his bio information and speaker information is on the back of the agenda, and that's something that we'll include with our package as well. So I'll let you read through that instead of identifying anything more than that. I'll let Robin kind of take that from there.
Right, well, thank you, Joanne, and thank you all for coming here. I hope you'll go away at least a little wiser than before. We'll certainly do our best to make sure that happens. I'm going to get right into it because what I'd like to do is to make sure that I finish in enough time for everybody to have a chance if there are any burning questions. Often a lot of the good stuff comes out from the questions, and I'll be around afterwards if anybody has something that they'd like to ask as well. And let's see. Yeah, there. So a brief outline. I'm going to just give a little bit of a context to start off with what I think is what I've chosen to talk to you about today, what I thought might be relevant for you. And then we'll get into some of the basic processes, as Joanne said, lake levels and fluctuating lake levels, which are always an interesting topic. A brief overview of coastal processes that on sandy beaches in particular, because that's more relevant for Kincardine. And then I will end with a couple of slides on what the future might hold in terms of climate change and how, not climate change per se, but climate change as it might affect those coastal processes. And I think Pete's going to talk quite a lot more about that. So let's look at the context. If we go a little bit south of here, down towards Horizon View and on down the rest of the coast, most of the people along that part of Lake Huron are really concerned about what's going to happen to my bluffs and how rapidly are they retreating. So that's much of the southern part of Lake Huron. If we go a bit to the north of Kincardine and Southampton, then we get into Sauble Beach, and here we've got exactly the opposite. Very gently sloping, sandy beach with dune system and dunes in the back and so on. So again, quite a different thing. If you go up on the Bruce Peninsula, you're into the Niagara Escarpment that backs you, and then in lots of places your beaches are big cobble beaches derived from erosion of the limestones in the and then we get to places like in the Huron Park. This was taken in May of 2006, as you can see, and it probably looks, well, I know it does look a little different today because we were there. Yeah, and the fact that it looks different today doesn't mean that there's something wrong. That's just the way it operates, And so it was nice and wide beach and a nice sand dune in 2006, and now it's a lot narrower, and the sand that's gone is doing its job out there. And we'll talk a little bit more about that. Okay, so I'm going to begin with a little bit of sort of backgroundy stuff. I hope this is you find this interesting. So the bedrock geology is one of the underlying things that controls how our particular shoreline looks like. Most of the lake basins are excavated in quite weak rocks, as you would expect. They eroded. And the strong units, like the Canadian Shield, which forms the shoreline all up the north shore of Lake Huron, Georgian Bay, and then onto Lake Superior, and the Niagara Escarpment dolomites, are all really hard. And that's what gives the shoreline. So the lake basins are in between that. The initial erosion of that whole landscape took place over about 100 million years or more, largely by rivers. But the lake basins that we see are really deeply scoured, and they can't be excavated like that by rivers. And so what we'll find is that those basins were scoured as a result of glacial advances and retreats over the last 500,000 years. So now we're not 100 million, but 500,000, okay? And all those basins except Lake Erie actually get scoured well down below sea level, which rivers don't actually do. So the maximum extent of the ice in the last glacial period happened about 25,000 years ago. And at that time, glaciers extended right down into what's now the US. Of course, it wasn't there in those days. And then as we come closer to this, after 25,000 years ago, things get a bit warmer, the ice melts, it thins, and the margins of the ice retreat. Now remember, the ice is always moving, and it's moving in general from north or northeast towards the south, but the margins retreat in the same way that the Athabasca Glacier is retreating up, for those of you who've been out there. Okay? And so about 12,500 years BP, it's now retreated, the margins have retreated so that bits of water, the lake basins in Michigan, Erie, and so on, become exposed. And because they're basins, all the meltwater coming off the ice fills them, so we've got lakes there that are proglacial lakes, just like you see in Greenland, for example. At this time, one of the key things is that there's still ice occupying the Lake Ontario basin, and so the water that's in these lakes doesn't drain out to St. Lawrence as it does today. It actually drains south, out of Michigan in this direction, and some of it goes to the Hudson River here. So it's quite a different situation to what we see today. Okay, so now we come down to the thing that I think is more important for Lake Huron, all right? Down to about 9,500 BP. And what's happening here is that the ice was, say, 3 to 5 kilometers thick. So you've got this whole weight of ice sitting on top of the Earth's crust, and that's enough to depress it, and sort of semi-liquid magma underneath flows away from it. Now this ice is all gone. We're ice-free now, but the whole area up here is still recovering from the weight of that ice, and it kind of recovers slowly, a little faster to begin with, and at the end more slowly. So when that happens, so while it's depressed, the water flowing out of the lakes now seeks the lowest level, and it turns out that flowing out into the Ottawa River and down into the St. Lawrence, which is now open, is the best way for it to go. It's actually the lowest outlet. It's so low, in fact, that the water in Lake Michigan and Huron is very, very low. The lake here is separate from Michigan, and there's a lake in Nottawasaga Bay, in Georgian Bay, that's also separate. The lake level has dropped by about 100 meters because this land is so depressed. Not, you know what I mean? Yes, yeah, okay. So we have those separate lakes, and one of the interesting things that's got really nothing to do with what we're talking about here tonight, but the water flowing out of Lake Huron flows between Tobermory and Manitoulin Island. It flows across the escarpment, and it flows down that big drop. So we've got, at this time, Niagara Falls North up there. And people have actually been out there with submersibles exploring this sort of thing. Okay, so this is where we really get into stuff that's important for Lake Huron and for us here. So the ice is gone, and the land is now rising. And as it rises, of course, it's like putting another sort of slab into your weir. It blocks more and more of the outlet. So as it's rising, the lake in Lake Huron and Georgian Bay is also rising. And it keeps rising until it gets to the point where the lowest level is now not going through into the Ottawa River, but actually to find that passageway out into the Detroit and the St. Mary's Detroit system at Sarnia. And so the water starts flowing down there. It gets rid of all the sediments from the ice and so on that were in that, and it opens up flow now into Lake Erie. And Lake Erie says, wow, I love this. There's all kinds of more water coming in, and so it rises up to its present level today. And then the sediments in that river from Sarnia on get eroded a bit, so the lake level drops from this high point about 5,000 years ago until 2,000 or 3,000 years ago it reaches pretty well what the level it is now. Okay, so this just illustrates that. So about 12,500 years ago, we've got a lake sitting there butting up against the ice. It's up here at this level. Then the outlet opens up and it drops dramatically down to here. And then the rebound starts and things come up. And about 5,000 years ago, we get to the maximum level, termed Lake Nipissing. And we can see that Nipissing shoreline because it eroded bluffs. And for those of you, if you're in Kincardine, you go down to the beach, you go down a hill. That's the old Lake Nipissing shoreline. And it becomes important see in a minute. So that's what we see there. So now we end up with the lake system that we see here today. We've got the major basins, Superior, Michigan, Huron, and Ontario, all eroded down below the level of sea level, Lake Erie up there. And water, of course, is flowing from Superior on down, all the way down, and then out into the St. Lawrence. There are only two places on that system where there are any controls so that humans can do something about it. One is the locks at the Sioux, quite neat spot if you've been there. And the other are a series of dams going from down Cornwall and so on, so downriver from Kingston. The outflow from Lakes Michigan and Huron is not controlled, and the outflow from Lake Erie is not controlled. All right, now we come to Kincardine and to this part of Lake Huron. We've talked a little bit about the glacier weight, and now it's released, okay? And so the land is rising, and it rises more quickly at the beginning than at the end. It takes maybe 20,000 years or more to do that. The key thing for Lake Huron is not how fast I'm being uplifted, but how fast I'm being uplifted relative to the exit at Sarnia, because the outflow is the key thing here. And so what I've done in this thing is to take the absolute elevation uplift that's going on today and put Sarnia as 0. So this line here means that's the 0 line. Everything in green up here, the land is rising faster than the outlet at Sarnia. So it's doing this, right? And so up here, it may be 30, 40, 50 centimeters a century that it's rising. Okay, so well, that's quite good, I suppose. Actually, the lake doesn't care. It doesn't think if it's good or bad. But anything that's in blue here is falling. The rate of uplift is less than at Sarnia, so it's doing, while the north is doing that, the south is going down. So if you happen to live, and I blocked it out just because I didn't want to offend them, but down here is Chicago. If you live in Chicago, the water level is rising there all the time. And so they have problems all along the Chicago waterfront, okay? All right, so what does that do for us in here? At Point Clark, the shoreline, so this is really basically at the south end here. At Point Clark, the uplift is about 10 centimeters a century, okay? So that's quite, you're a little taller than you were, some of us are a lot taller, I think. Yeah. It's about 10 centimeters a century, and up at Parry Sound and Tobermory, it's more like 30 centimeters a century that they're rising. And we'll come back to that because I don't want to say anything to offend people in Georgian Bay, but they have a little more uplift, and they've got some problems with that. It also has some, there's one other lake where it becomes an issue too, and that is Lake Superior, because then you do the same sort of thing for the outlet at the Sioux, and you look at how the shoreline is rising relative to that. And what we find is that essentially all of the Canadian shoreline is going up, and all of the US shoreline on the Duluth and places like that is going down. And if you sit on the committee of the IJC, where you've got Canadians and Americans, that becomes, we can sit back and say, our land's rising, your land's falling. You have the problem, we don't, kind of thing. Okay, so what are the implications? South of Point Clark, just a little past Amberley actually, at Horizon View, we've still got ongoing erosion. And as we go further south, it's going on. So even if they've got 2 or 3 centimeters a century of rise, the erosion underwater is going on faster than the uplift from the isostatic rebound. Okay. From Point Clark northward, the land is generally rising faster than erosion, and that's why everywhere from within the Saugeen and up there, we don't have much. There are a few areas where there's still erosion ongoing, but nothing like what's going on south of us. And that's why people in this area are actually really favored, fortunate, because you don't have those issues at the same magnitude we have down there. One little thing for those of you who may live along a gully, and that is that the gullies are, of course, the gullies go down to lake level. And because we're rising, it means that they have to continually cut down a bit to get to the lake. So there will be ongoing erosion of the bed of the gullies, and that kind of steepens the slope. So if you've got a gully next to your house, it's something that's something that you need to be aware of, because it could be an issue in terms of, it's no good your house not falling into the lake if it actually falls into the gully. Okay. Well, lake levels are obviously a big thing. This is the record. I think Joanne showed it. Sorry, let me go back there. The little fluctuations are the seasonal fluctuations, and then superimposed on that, we have these long-term fluctuations with highs. It's high here in the late 50s, 72, 85, 86, a little bit around 1998, and then coming up to the present high, and then lows there. And these long-term fluctuations, we now know they reflect things that are sort of from outside. So El Nino, La Nina in the southern Pacific. There's one in the northern Pacific, the Pacific Decadal Oscillation. And then there's also another one called, I think it's the North Atlantic the North Atlantic Oscillation. So these are broad factors that control the movement of the jet stream and the movement of depressions in the mid-latitudes. So the range is about 2 meters on Lake Huron. Why does it fluctuate? Well, we can go back and a whole heap of people, hydrologists in the Environment Canada, in the US, Army Corps of Engineers and so on, who work on this sort of thing. They know an awful lot more about it than I do, but here's a basic summary of it. The inputs to the lake are from precipitation, rain and snow, and now more rain than snow. The runoff from the basins, this is this one here. So this is the water that falls on the land and comes into the lake through the rivers and gullies and even the groundwater. And the third one, of course, is that there's water that comes out of Lake Superior into us, and it actually accounts on average for about 35% of the input into Lake Huron. So we have to take note of what Lake Superior is sending to us. The outputs then are evaporation from the lake, and then the outflow down from Sarnia into Lake Erie and on down the system. If we get a lot more precipitation, then the lake level rises. Often when we get more precipitation, we may get less evaporation, but in any case, the level will rise until the outflow, the water going out at Sarnia rises enough to transport everything out. And so there's a balance. And when we get very little precipitation and there's losses through evaporation and down here, then the water level in the river draining from Sarnia goes down, and so it all balances out. And so there's a neat balance going on there. Well, in the last 4 or 5 years, we've had a rise of about 2 meters from almost record, or record lows in a couple of months, to record highs again, or very close to record highs. Pretty rapid in the first 2 years, a little less rapid now. And I could even say I don't think it's going to get much higher, if any higher at all. Now, you heard it from me, but please don't hold me to it, you know. Deal with the Army Corps of Engineers or Environment Canada if you want to blame somebody for it. Okay. I think one of the things, though, and this is that the record levels are record levels by a few things, and they're not huge. There are some constraints on how high the water can go, simply because the higher the water goes, the deeper the flow going out through Sarnia, and it can transport more. The water is deeper, there's less friction there, and so it goes faster. So there are limits to that, and so far it seems that works. There are also limits to how low it will go, and again, that's because we constrain the outflow. As an aside, and I'll come back, this is to the Georgian Bay people, in the mid to late 2000s, the people in Georgian Bay at the height of that low levels were complaining bitterly because their docks had to go a long way out, or they couldn't bring their boat in anywhere, or you were driving your boat over that shoal that you could always drive it over, and all of a sudden you've lost your prop. And so they asked the IJC to look and see, did somebody pull the plug a bit? Did they dredge the river too much? And the results came back saying it doesn't seem that they did. But what we can see now, I think, is that if they had dredged, there was actually an increase in the dimensions by dredging at Sanya, we wouldn't likely be dealing with the high lake levels that we are now. They should be this much lower than they are. So I think that's probably, let's leave the outlet alone then for the moment. Okay. So flows contained out of Lake Superior controlled by the locks at the Sioux. In 2008 to 11, there was a study by the International Joint Commission, which all of you I'm sure know about, which regulates any waters between us. And so this examined, first of all, to see whether they could tweak things in the regulation of the locks to benefit everybody. Because one of the problems is you're trying to satisfy hydro, marinas, shipping, all these people. And what's good for one isn't necessarily good for the other. So they try and get a balance in this. In the end, it seemed that what you've got is what's best for everybody. Nobody benefits the most, but everybody gets something out of it. The other thing they examine, and this is interesting, and it comes back to high lake levels now, is of course when you get high lake levels, and some people start to have issues with their house being too close to the water, is that you say, well, could we do something about that? And so they examined whether we could regulate the outflow from Lake Superior coming into Lake Huron to make things easier for people in Lake Huron. And a lot of the people who were gung-ho for this were people on the west coast of Lake Michigan who were really having a rough time with erosion and so on. And a couple of them on the committees with us. In the end, it turned out that they tried all kinds of things, but one of the big sticking points is that if you're going to reduce lake levels in Lake Huron, you've got to hold back some of the water in Lake Superior. Well, this comes back to what I said about people who live in Duluth, because the people from the south shore of Lake Superior are saying, it's hard enough for us already, and now you want us to take even more drowning because of what somebody down in east-west coast of Lake Michigan says. So very difficult to do. Unfortunately, we were able to stand back and say, you guys fight it out among yourselves. But it shows some of the difficulties when you get into regulation, and that is, it's very difficult to anticipate what's going to happen, weather-wise 5 years from now or 2 years from now. The other issue is, of course, that much of the time, high lake levels in Lake Huron, Michigan, coincide with high lake levels in Lake Superior. If Lake Superior levels are down, well, we can hold back some water. But right now, Lake Superior levels are also at record levels, and the outflow from Lake Superior is, I think it's something like 105 versus 83 is the average, thousands of cubic meters a year, whatever the number is. But it's like 20 or 30% more. Okay, so let's get down to sandy beaches, because there are quite a lot of them in this part of the world. And this, of course, is in the Huron last November, I guess it was. Sandy beach with a dune there, and not a very wide beach, and not a lot of grass on the beach either, you'll notice. Okay, so what are the things that are doing this? Well, two things: lake level fluctuations, of course, but also what actually erodes the sand and the beach and so on are waves. And so I'll just talk a little bit about waves. This is waves 101, maybe less than that, I don't know. So waves are generated on water by winds blowing over the water, and the energy is transferred from the winds to the water. And this is a picture from a little pond in PEI, and you can see here that the wind is blowing directly towards me, standing over here on a nice boardwalk, and there's no waves here, and then the ripples are formed and get bigger and bigger down in this direction. So the wind transfers the energy to the water surface. That takes the form of waves, and the waves get bigger as they come towards you, and the waves travel basically the direction that the winds initially do it. And certainly in the lakes, that's mostly what we see. We're not here in the Pacific. Okay? So waves increase in height and length downwind. And that length over which they're traveling is called the fetch length. So what controls how big the waves get? Because the bigger the waves, I think we all know, the greater the energy that's going to transport sediment or erode the bottom of your bluff or undermine your seawall or whatever it is. So wind speed is the first thing. It increases with increasing wind speed. It increases with the duration of the wind, because if we have 100 kilometer-hour winds blowing for 1 hour, you don't instantaneously end up with 10-meter high waves. It takes a while to do that. So the duration gives a limit to it. And then finally, and what's very important for the Great Lakes, is that the fetch, the distance over which you have for wave generation. So in the Pacific, you may have thousands of nautical miles over which the wind can blow. Here we've got limits because we've got the other shore. So what fetch length does is it acts to limit the amount of time that the wind can be building those waves up. Because you start off here building the waves and they get higher and higher, and then bam, you hit the other side. And that's it. So that's the crucial thing. And in this area, these are the key ones that you have to look at. The longest fetch is to the northwest, something in the order of 150 to just over 200 kilometers. And that means you're going to get your biggest waves from there for the same wind speeds. Okay. The nice thing about here is that those waves are coming directly in. It has a few problems for cottage owners, but what it means is that the sediment transport isn't all moving in one direction. When you get down to south of Point Clark here, those waves come at an angle, and so all the sediment is moving. And for the people who want to keep a beach here, it's all going down to Grand Bend and Pinery Park. Your sediment, your sand, is mostly contained here. You're not losing huge amounts of it to supply somebody further away. Okay? Always nice, yeah. The fetch lengths for the west and the southwest are much shorter, and so we tend to get smaller waves from those directions here. And the southerly winds, southwest and so on, will tend to drive stuff in this direction. So you may actually have a bit of sand going from around here to supply Sauble. Not that they need any more, but they'll take it. Okay, and there is a little bit of sheltering to Point Clark here. It shelters you a little bit in that direction. Okay, so lots of people, a lot more intelligent than I am, have figured out exactly how waves are generated, and they can predict what the waves are based on things like the wind speed, the wind direction, the temperature of the water, the temperature of the air, and so on. And we've got models now that allow us to predict those waves, and we can distinguish between how we use them on the basis of forecasting. So if you're interested in, can I surf tomorrow off Kincardine, then you want the wave forecast for tomorrow. And if you're interested in what sort of waves are the shore protection structure I'm designing going to be subjected to, then what you need is something like 10 years of wave data to tell you, well, once every 3 or 4 years we're going to get waves this high and this length, and they're going to come from that direction. So that wave hindcasting uses meteorological data. Environment Canada has got. Or we can have, as we now have for most of the Great Lakes, wave buoys out there that actually measure the waves, so then you've got the real measurements to work with. Okay. It does depend a little bit too on where your waves break. On a sandy beach like at Sauble, waves break a long way offshore. If you're at a bluff coast a bit south of here, they break right against the bluff, and so you've got more energy there. Okay. Sandy beach and dune systems. We've got a foredune, the back dune area here, the beach down here. This is taken several years after a storm, so we've got vegetation on the beach forming little embryo dunes. And this is where, if there's a big storm, all this stuff gets wiped out and it starts eroding the base here. So that was in PEI where I've done a lot of work, but we still got some pretty good dunes here. Some of them, like this, is just at the foot of the bluff, and in the low water levels we get a nice little dune built, and then all of that goes and the waves reach the toe of the bluff. Okay. Some of it's like we saw at Inver Huron, and so we had a lot of beach out here. All that veg is gone, and now we've just got the dunes cliffed. And this is kind of a going off towards Inver Huron. Very, very simply, a lot of the work that I've done has been looking at beach-dune interaction, this interaction between the beach and the dune. And the way it works is that in big storms, and particularly in the lakes during high lake levels, the dunes get eroded. So the water level gets up, the waves are bigger, and they erode the dune. And this is from a big storm in December 1985 in Long Point. The dune went back about 15 meters here. You can see some of these poplars, which started growing down here. They were they were buried by the dune as it grew. They're now exposed because the dune has gone back. So that's the erosion part of it. And what that happens is that sand goes back into the water. It goes out into the nearshore bars. It dissipates the wave energy, and so it in fact slows down the impact of the waves inland. And the dune itself, if it's big enough, is a wall. It's like a dike. It's protecting you. So if your property is on the other side of this, you get a little worried, and you're not laughing too much, but it's there. Your house is safe. Okay. In the intervening periods where you have either no storms or no big storms, or you have lower lake levels, then sand gets blown off the beach, it gets trapped by the dunes, it builds the dune back up, and this is what you have. Same place in on Lake Erie at Long Point. So all that's there now waiting, and in fact it's doing its job right now because lake levels on Lake Erie are also high, and so this is cut back to about here now as a result of that. The rebuilding takes, of course, several years instead of just a few things. And what am I doing here? Yeah, okay, that's good. I can do that. So when levels rise, as they've done in the last 4 years, after below average, then the waves erode the beach, they erode the toe of the dunes. The embryo dunes are eliminated first, and then the beaches remain narrow. When the rise is rapid, as happened between 2014 and 2016, then the sandbars offshore, which break the waves, tend to migrate onshore, but they may do so more slowly than the water level is rising. So those first 6 months or so, there's a bit of a lag then, and so the beach is subjected, and your dunes is subjected to more wave energy than when everything sort of stabilizes. So I don't know if any of you had problems with Phragmites on your beach. A number of people I've heard from the Lake Huron Center about that. There's no more Phragmites out on the beach right now, so thank good. That's one good thing about the rising lake levels. Beach widths will be narrower, and this is a time when you need to make sure that the vegetation on your dunes that's surviving is healthy. Don't trample it all down and remove it, because you need that vegetation there to go back down onto the beach and start trapping more sand. And in general, I think the people from Saugeen will tell you, if your buildings are set back beyond the dynamic allowance, you shouldn't have any hassles at all. You should be safe that way. Okay, I'm going to end with 2 slides that talk about climate change, because Pete's going to talk a lot more about this. The lake levels, early models suggested that there would be more loss of evaporation and therefore lower mean lake levels. Now I think it's becoming, the models are suggesting that increased loss through evaporation will be compensated for by more rain. And maybe this year is a sign of that. Last couple of years, we certainly had lots of rainfall, and that rainfall in particular will be in the northern parts. So for the moment, we're as well off to say, let's assume the historic mean lake levels are going to be the same, and let's look at what happens in terms of lows and highs, whether those will change. let Pete say what he thinks. At the moment, I don't think we know for sure what's going to happen in that respect. They're probably not going to go much different from what we have, simply because of the constraints of the outflow. There's no constraints on the outflow. So if it rises, more water goes out of Lake Huron, Michigan. So I don't think we're going to look at, say, 30 centimeters above what we see now, or even 20 centimeters. I think what you see now, I'm saying it for the second time, what you see is what you probably got. Okay. The one thing that is going to change, and is already changing, is how much ice we have out there. And there are different ways of measuring the ice. I've done this one here, and what I've taken is we have daily measurements of ice cover since 1973. And what I've done is to take the number of days when the ice cover on Lake Huron exceeds 20%. Because once you've got 20% ice cover, nothing much is going to happen. There's very limited wave generation and so on. And to cut a long story short, if you do that for that time period, what we'll see is that if we go at the beginning, we've got about 95 days with ice cover greater than 20%, and now we're just below 60 of those. So it's just one bit of evidence, and the key thing here is that the more you've got open water in the winter season when storms are strong, the more likely you're going to, more large waves you're going to be subjected to. So that 10 or 15 centimeters of uplift per century that you have here is going to be very good for you. Okay, and that's it from me. I think I've got one more.
So we do have time for a few questions, and what we'll do, because we do our recording here and on live streaming, that we'll try to repeat your question, and then Robin can do his best to answer. We got about 3 or 4 minutes, and then we'll get into Peter Zuzak's. Go ahead.
Can I go? Okay. We own a property, one of the properties at the south end of Kincardine that's literally on the beach, like it's there. And so when the water was high before we owned the place back in the, I don't know when it was.
86.
Yeah, 87 or something like that, I don't know. It wiped out, it took away most of the hill that the cottage is right beside, and the people put in something I've never seen anywhere else. It's a series of concrete, they look like fins, like they're curved. And the original idea was they were supposed to give a bit right up and down on poles, which were never installed. So your comment about vegetation, the last few years, off and on, we've had sand gets dumped in there, and we've had all kinds of things growing, but the soil is only about this deep in those things. Someone had told me, an engineer friend, said that I should take all that out because it'll mess with how the concrete works. And I'm thinking I should just let nature do what it wants to do and let whatever grows there grow. Do you have a comment on that?
Yeah, so the question really is, my neighbors put in, or actually this is, your neighbors put in these concrete,
it's not the previous owner.
Yeah, previous owner, okay, have put in shore protection.
Sitting on bedrock.
Yeah, have put in these shore protection structures, and you're not sure they're doing any good, and maybe if sand accumulates and you get vegetation on it, that might actually be good. And I mean, without, obviously, nobody can give you a thing without coming to your place and looking at it. But depending on where you are, certainly encouraging dunes to develop, if you've got sand there, means allowing the vegetation. And the vegetation can't do any harm. Certainly not in the scenario you've given to me. And talk to the people at Saugeen because and at the Lake Huron Center, because they've got people who are experts on that. Yeah.
Thank you.
You mentioned that you were about the dredging at St. Mary's, whether it was affecting Nottawasaga. What about the dredging that was done in the 60s in Sarnia to widen and deepen?
That's what I was talking about. At that's at the entrance, Sarnia, to the entrance of the St. Mary's River. Yeah, and that it probably did lower it temporarily, but there's all kinds of gravel and sand in there, and it just infilled it. It's very difficult to keep that dredged. In fact, because for shipping, in the shipping channels, they have to keep doing it because it fills in, and that's if it ever was lower, it isn't any longer.
Okay, we'll take one more question, maybe. Yeah.
So one of the things we're on Bruce Beach, which is beautiful sandy beach, but there are certain people that have removed their grass. I don't think it's supposed to be done, but it has been done. Can you emphatically say that to reduce erosion going forward, we shouldn't be removing grass in order to have a nice sandy beach in front of our cottage? Or is that really just something that, people think as opposed to
So the question is, should you remove grass to have a sandy beach, or will it in fact do something to retard erosion of during high lake levels?
Purely retarded.
Yeah. There's a trade-off you have, yes. Your beach will be narrower during periods of high lake level, and so people will remove grass to just get a place to sit. In the long run, it's probably not the best way to do it, but again, I can say generally, I'll wave my arms because I've done a lot of stuff up and down, beaches and dunes, and I can tell you, in general, if you've got a healthy dune, you have a much better chance of protecting yourself than if you don't have. And a healthy dune means having vegetation on it. There may be, and somebody again would have to come out at your beach and say, are there issues that we can deal with here or not? But in general, what I'm saying is, yes, the grass is a good thing.
Good. Round of applause, and thank you to